In this video, we are going to see about the formal language, that is string properties. Okay, so first we will see what is the alphabet. So an alphabet is a finite set of symbol which is denoted by the sigma. So for example, if you are going to use the input value alphabet simple as a comma b means sigma is equal to a comma b. Otherwise only the binary value sigma is equal to a comma b. So otherwise if you are going to use the character alphabet, it may be uppercase or lowercase. So we can give sigma is equal to lowercase abc up to z and uppercase abc up to z. Then if you are going to use the numeric value means sigma is equal to 0, 1, 2 up to 9. Okay. The next is string. A string over some alphabet is a finite sequence of symbols drawn from that particular alphabet. So for example, if you are going to use the input value, so that is a alphabet that is the symbols if you are going to use 0 comma 1. So how we will write sigma is equal to 0 comma 1. Then what will be the string here? So the strings are any combination of the value. So that is 0, 1, 1, 1, 1, 0 or 0, 1, 0, 1 or 1 up to any values. So this is the string. And the term sentence and word are often used as a synonyms for the term string. Then length of the string yes, it can be written as within the modulo yes. So that is number of occurrence of the symbol in the yes. Okay. So for example, we have taken the special string as a banana. Okay, we have taken the special string as a banana. So what will be the length? So the length of this one is 6. Then empty string. So the special string we are using here with the length 0, that is a epsilon symbol. So for the empty string we will use the simple epsilon. Then the reverse of the string. So the reverse of the string u was denoted as u power r. So for example, if the u value is ab, then what will be the ur? It is ba. Okay. Then next, these are the some common terms which is associated with the part of the string. So a prefix string is yes is a string obtained by removing the 0 or more symbols from the end of yes. So that means, for example, we can so that will be 0 or more symbols. 0 or more symbol means only epsilon can be there, or prefix means we will consider from the starting of the symbol. So that is only ba, then ban. So these are the prefix string. The next one is a suffix string, suffix of the string. So any string obtained by removing 0 or more symbol from the beginning. So here we are going to remove the symbol from the beginning. In a prefix we will remove the symbol from the end. So 0 is also allowed. So epsilon, then na, then bana, only na. So these are the suffix of the string. Then substring of the s is obtained by deleting any prefix and any suffix from the s. So we can delete any prefix or suffix. So only nan, then epsilon also. Okay, so this is a substring. Then proper prefix, suffix and substring of the string yes or those prefix, suffix and substring respectively of yes that are not epsilon or not equal to the yes itself. Okay, so it doesn't contains the epsilon. Okay, it doesn't contain the epsilon and it is not equal to the yes value. And subsequence of x is any string found by deleting the 0 or more non-necessarily consecutive position of the s. So for example, subsequence, for example, ban. So it is a subsequence of a banana. Okay, so deleting the 0 or more not necessarily consecutive positions. The next one is a clean closure. a set of all the string including the empty string on the alphabet, it is written as epsilon star. Okay, so this is also known as clean closure or a clean star after the famous logician who was one of the founder of this particular concept. So clean closure. So for example, if sigma is equal to 1. Okay, so then how we can write the clean closure? Epsilon star is equal to, if it is a clean closure means empty string is also allowed. So epsilon 1 1 1 1 1 1, let's go on. Okay. Suppose if the input simple value is a comma b. Okay, so then what is the epsilon star? That is a clean closure. So epsilon, empty is allowed, empty string is allowed. So epsilon, then a b, a b, a b, then b b, b b a. So any combination is allowed here. Okay. The next one, a language. So the term language denote any string over some fixed alphabet. Okay, so it is denoted by L, and L belongs to epsilon star. So that is, let sigma be the alphabet and sigma star be the set of all the strings on the alphabet sigma. So any subset of clean closure is called as language over the epsilon or language with the alphabet. Okay, so generally we are denoting L is equal to L belongs to clean closure here. Then abstract language pi, the empty string or epsilon, the set contains only empty string or language under this definition. Okay, so example, all synthetic well formed Pascal program forms the language, or grammatically correct English sentence from a sentence form the language. Then operations of the language, there are several operations. It can be applied to the language. So the operations are union, concatenation, clean closure, and the positive closure. So union, L and M. So that is L union M. So that means the string is in L or the string is in M. Okay. So we are combining both. Then concatenation of the M. Uh, Concatenation of L and M. So LM is equal to the statement, which is what we are doing. We are adding the string L and M. Then clean closure of the L. So that is L star. So we can denote as a L star. So it contains empty and the other strings. Then positive closure, that is L plus equal to U union. So that is U. I is equal to 1 to infinity Li. So it doesn't contains the empty string. Okay. So it doesn't contains the empty string. And then next, concatenation of the string. If x and y are the string, then concatenation of x and y return xy is the string found by appending the y to the x. For example, if x is equal to dog, and y is equal to house. So xy is equal to dog, house. Then empty string is identity element under the concatenation. So that is, if s string epsilon is equal to epsilon s, it is equal to yes. So it is identity element under the concatenation. The next one, string exponentiation. So defined S0 to be the epsilon for I is greater than 0, defined Si to be Si minus 1 S. So since epsilon S itself, S power 1 is equal to S. So otherwise, if S power 2, so it is SS. If S power 3, it is equal to triple S. Then we will see some more example. So let L be the set of A, B, C up to Z, then lowercase a b up to Z, and D is a set of 0, 1. So L union D, it is that means we are taking the union, right? It is a set of letters and the digits. It contains letters as well as the digits. The next one LD. So here LD means it is a concatenation. So set of strings consists of letter followed by the digit. So why letter followed by the digit? First there is a L. So L contains the string of set of alphabets. So first string value, then digit. Then L power 4. So L power 4 means it contains set of 4 letter string. Okay, it contains set of 4 letter string. Then L star. So it is all, let's set off all the strings, set off all the strings of the letter include epsilon. Okay, epsilon. So it is a empty string. Then L union D the whole star. So here that is the string begins with the letter. Okay, string begins with the letter and digits. Okay, strings of letter and digit begins with the letter. So first it contains the letter, then it contains the any combination of letters and the digits. Then D plus, it is set of strings of one or more digit. So it doesn't have an empty string. It contains one or more digits.